So this is the question. Batman is traveling in his Batmobile, and he is chasing Joker. He travels 185 meters straight west, then a distance of 220 meters in a direction 45 degrees east of south, then a distance of 287 meters at 30 degrees east of north. Batman travels one more displacement and ends up where he started. What is the magnitude of the fourth displacement? So even though that's a lot of information, the one thing we can focus on is he ends up where he started. That means that all of this will add up to be 0. Each one of these vectors will add up to be 0. So all I did was draw this, and so what we can do is find the x and y component of each of these vectors. Because right now, to find this, we can't just cancel these out because they're not the exact same. They're at different angles. So therefore, we need to separate them into their x and y components. Therefore, we can cancel those and find out exactly what we need to make it 0. So I just made this A, B, and C just randomly, and then so let's start. So here I put the same thing, 185 meters west, and so the thing to note is that it's on the x-axis completely, meaning if I go here and I'm on the x-axis and I try to go up, I can't because the entire thing is on the x-axis. That means the entire x component is 185 meters. But also, since this is the negative part of the x-axis, it's going to be negative 185 meters. Once again, this is going to be the x vector, and vectors have direction, so that means that it needs to be positive or negative. And in this case, since it's on the negative side, it's going to be negative. So since we've determined that all of it is on the x-axis, that means that there's nothing on the y-axis, so that y component is 0. Moving on, we have B. B is going to be this one, 220 meters. So going down, I just drew that, 220 meters. But in the question, what it actually said is it said 45 degrees east of south. So if you have south, that means east of south, you're going this direction, it's going to be the angle right there, in between that. That's what I drew right here. The angle is going to be, this is south, and so as you go east, it's going to be this angle, and this is going to be your vector. So then I created this triangle. All I did was use the y-axis as this side, and then I just shifted the x-axis down to make this triangle. So now we do some trig to find the x and y components. So the side opposite is going to be opposite, adjacent, and the hypotenuse. So let's solve for the x component. So we have opposite over hypotenuse because that's the only number we have. So it's going to be sine of the angle because that's opposite over hypotenuse. So it's going to be sine of 45 degrees equals opposite over hypotenuse. So sine 45 equals, and then just plug in what the given information, 220, and you're going to multiply each side by 220. You get 155.6. And now go back and make sure you know which component it is. Since we were solving for the opposite side, and side is correlated with the x-axis, it's going to be the x component. So it's going to be 155.6. And then we have to look, is this positive or negative? Because since this is a vector, it has to be positive or negative. So we look, and since this is on the positive side of the x-axis, it's going to be positive. Finally, we have to look at the units, and it has to be meters because that's what we've been using, meters. And we don't have to worry about sig figs right now, significant figures, because since this isn't the final answer, we can leave it. It's actually better to leave it with more sig figs because if you don't, you'll have rounding errors. Now moving on, since we just found the x component, the next one has to be the y component. So we can predict stuff because since this is going to be adjacent over hypotenuse, since this is going to be a vector, we can predict the units and the direction. So the units are going to be meters, but the direction, since this is going down, it's going to actually be negative, because down is the negative part of the y-axis. So we can predict that this is going to be negative, and the units will be meters. So let's go down. So it's cosine 45 degrees equals negative, because it's going down, negative adjacent over hypotenuse. So it's cosine 45 degrees, and then you just plug in the information, which is 220. You'll get negative 155.6, and then you check it to make sure it's the y component. Yes, because the adjacent is correlated with the y-axis. Go back down. Y component equals negative 155.6. Significant figures don't matter right now, because we still need more calculations, and then units are meters. And it's negative, because that's the direction, because it's down. Now the final part, it's part C, and then going back up to the question, it says a distance of 287 meters at 30 degrees east of north. So we start at north, and it says east of north. So the vector is going to be here, and we're finding the angle right there. So we go to part C, and here we go. So we have, like it said east of north. So we have north, we go east, and there's our vector, and there's the angle. So this is going to be our vector. So all I'm going to do is make a triangle so we can do trig. So I'm going to shift this x-axis up so it makes a triangle, and then there we go. This is a triangle. So once again, I'm just going to do trig to find the x and y component. So then we can ultimately solve the magnitude of the fourth displacement. Okay, so we have the opposite over adjacent, and the only information we have is the hypotenuse. So we just solve for it. So we have sine of the angle, 30 degrees, over opposite over hypotenuse, so that's going to be sine. So, and then we once again, we can predict it. We can say that's going to be positive because it's on the positive side, and it's going to be meters. And then sig figs don't matter. Okay, so now that we have that, we just plug in information, 287, multiply it by 287 here, we get 143.5. So, and then confirm that, yeah, this is the x-axis, so the x component is 143.5, the units are meters, so we're good. Now the next one, we can predict this one too. It's going to be meters, and since it's pointing up, this is positive, so the answer will be positive. And okay, so it'll be adjacent over hypotenuse, that's going to be cosine. So we go down, so it's going to be cosine of the angle, cosine 30 degrees, equals adjacent over hypotenuse. We just fill in the information, 287, multiply by each side by 287, you get 248.5. You confirm that this what you just solved for is the y component, and it is because it's up. So it's a y component, and it's going to be 248.5. We said it's positive because it's up, and then the units are going to be meters. Okay, so now we finished finding all the x and y components. Now we just go back up and record each one of them. So here we said it was negative 185. Here we said it was 155.6, negative 155.6, and here 143.5 and 248.5. So all I'm going to do is draw all of that. And I just labeled all that information here, like all the numbers you just saw. So now what we can do is we can add, since these two are on the same side, we can actually add these two up because they're going the same direction. So their forces are going to combine. If you imagine this as people, right? 248 people pulling, 155 people pulling that way, 185. If there's 155 here and 143 here, and they're all both pulling the same direction, you can add those up because they're both pulling the same direction. So with that, here we go. We have 299.1, and I just redrew all the other arrows. So like I said, if this was a tug of war, 299 people are pulling this way, 185 people are pulling this way. The 200 is going to win, so this is going to cancel out, and you can add these together, but the overall force will be going that way because there's more people. Here, the same thing. 248 people are pulling this way, 155 people are pulling this way. You can add these together, and then the total force will be going this way because this one's stronger, there's more people. So then you do that, and you'll get 92.9 and 144.1. Okay, and then we ask ourselves, what is this actually? This is the combined force of all three of those segments, A, B, and C. This is the combined force. But what was the question? The question was, what is the magnitude of the fourth displacement? So we want something, and since we said it ends up where he started, that means that we want something that fourth displacement to cancel out those other three displacements. So we go down, and right here. So we want something that cancels it out. So all I did was draw in the opposite direction, something that makes this 0, and that would be negative 92.9. Something that would cancel this out, it would be negative 114.1. So now since it becomes 0, now we know the y and the x component of that vector that will get us to 0. But we're still not done. So we need to find that vector. So since this is the x and y component of that vector is going to be right here. So what we can do is make a triangle out of that simply by shifting the x-axis down, making a triangle, and then plugging that information that we have. So all I did was just plug this information here, this information here. Now all I'm going to do is find this last piece of information. And what we wanted was the magnitude, which is simply the length. We want the length of the fourth vector, that displacement. So we can predict our answer. It's going to be positive because length is positive. You can't have negative miles. So it's going to be a positive distance here. So, and the units will be meters, unless they ask something different. But for this, since they've always used meters, we're going to assume the units are meters. So how we're going to do this is, since we have two sides, we're just going to solve for the third side. So that's going to be just Pythagorean theorem. We're going to plug this in, and we get 147. But we weren't done because we know that it'll be positive because it's a length, and that the units will be meters. Now, another question, the second part, would be, what is the direction of the fourth displacement? We have the actual length of the displacement, the magnitude, but what is the direction? Well, what that means is that direction is not just like north or south. It's the angle of where it's pointing, of where that vector is pointing. And so what they want is the direction of the fourth displacement south of west. So this is west, so it's wanting us to go south, so this will be our angle. So, and this was our vector, so they want this angle. So we can do that. All I did here was put the same information. I just have the x-axis and the y-axis. I just shifted that here to make the triangle. I plugged in the same information, and all I'm going to do is solve for this little angle right here, because that's what they want, south of west. So we look, and we have what information they've given us. It's opposite over adjacent. We predict what the answer will be. So since they want an angle, this angle has to be positive because you can't have negative degrees. So the answer is going to be in degrees. And we can say that the sig figs are 3. For the most part, sig figs will be 3 unless they specify it or the rules show you otherwise. But here it'll most likely be 3, and so now we can do the problem. It'll be inverse of tangent because we're finding an angle, and then that will be opposite 92.9 over 114.1, and then you divide those and then plug it in the inverse of tangent in your calculator. Make sure it's in degree mode, and you will get 39.2 degrees. And let's say if one of these was positive, like it was positive 92.9, if you got a negative number, remember that you can't have negative degrees, so just make it positive. So I hope that helped, and thanks for watching.